So, hello student, today we are going to discuss another important topic of a heap management, that is dynamic memory management, that is reducing fragmentation. In last lecture we are discussed the things which are related to the hierarchy of a memory. Then we also discussed the things related to the memory manager. So fragmentation. Okay, let's take the example when suppose uh, in response to that, this is the synchronization between compiler and operating system, what is to be allocated and what is to be deallocated according to the programmer's code. Okay, but whenever deallocation which is to be performed at that time, small amount of chunks which is to be free up between the space. Suppose a to d which is to be memory allocated, but according to in between a and b which are available in a memory, but see, there is no any work, there is no any task which is to be performed on C. So C which is to be deallocated, but there is a requirement of D variable. So here A, B, C which is allocated in a memory, but there is a small chunk which are available between C to D. Okay, so this is what we can say, that this is the requirement, this is the requirement which is to be by the operating system to free up the space memory whenever the large amount of variable or large amount of database which is to be allocated. Okay, at the beginning of a program execution, the heap is one of the contiguous unit of free space exactly. But whenever the program which is to be allocated, variable which is to be allocated, at that time memory is allocated, deallocation which is to be performed. Okay, as the program allocate and deallocate memory, this space is broken up into the free up and which is to be used a chunk of memory, and the free chunks which need not reside in a contiguous area of the heap. So we refer to free the chunks of a memory as a wholes. With each allocation request, the memory manager must place that request chunk of a memory into a large enough holes. So unless a hole of exactly the right size is found, we need to split up some holes. Okay, with each deallocation request, the free chunks of memory are added back to the pool of free space. Okay, so we coalesce the contiguous holes into the large holes, as the holes can only get the smaller. Otherwise, if we are not careful, the memory may end up getting fragmented, consisting large numbers of small non-contiguous holes. So what will be the problem over here? So there are small chunks which are available, and if we okay, let me take example, uh, 10 MB, 10 MB and 10 MB small chunks are which are available, and at the same time we require the 30 MB requirement for the heap memory allocation. But at the same time we are only 10 10 MB, 10 MB and 10 MB of chunks which are available. So at the same time the operating system is not able to allocate the space for that allocation request. Okay, so this is the requirement, this is the what we can say, the necessity of the fragmentation, and in response to that, this is to be work which is to be done by the operating system in the behind. Okay, thank you.